Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at event interfaces within a class, within your application. We have completed a number of videos covering events. All of these so far have been events within the PowerBasic for Windows compiler. Today we're going to look at a series of events that can be set up either for the Windows or console compilers. We have also covered videos on the creation of a PowerBasic class. And we're going to combine both of these today to create an event class. One of the things you need to take into consideration when creating a class is what the class is actually going to do. In the application we're going to create today, we're going to create some background processing. This background processing will have a start, a middle, and an end. And we're going to create a class as an event which is going to allow us to report on these three states: the start of the processing, the completion of the processing, and the progressing of the processing. With an application that runs in the background, you may occasionally need to report on progress. This could be either in a console window or sending to some other application. Today's video will give you a template by which you can perform this. So what we will do first of all is we will set up a class as an event. This class as an event will lay out the blueprint for what we're going to be doing. So first of all, we're going to declare the name of our event. We're going to call that EV class. EV I'm using as a prefix to designate this class as an event class, purely for documentation purposes. We're naming the interface for this class as iStatus and declaring it as event. We'll come back to the status in a moment, and we're using the inherit IUnknown command. So within our event class, there are going to be a number of methods. One to say our processing has started, one to say it's completed, and one to report on the progress. We can create each of these methods by using the method keyword. For example, we're going to create a method called started. This will be called when our application starts. And anything within the method block can be executed at that point in time. All we're going to be doing here is we'll send a message out to our log to say that processing has started. And similarly, when the process has completed, we will create a method called complete, which will send a message to the log to say completed. We're finally going to create a method called progressing. However, we will park that one for the moment and we will come back to it. Let's now look at the main processing class. So as we've done before, we now have to create that class. So as we did before, we have specified the interface and given the interface a name of iProcessing. Again, this is inherit IUnknown. Within this, we're going to create a single method. This is going to be called runProcess, which will start our processing. Within this method, we're going to use the raiseEvent command. This will allow us to call the methods within the status interface. As you will see, we're using raiseEvent iStatus.started. This is referring to this method up here. This interface is called iStatus, the method is called started, and when this command is executed, we will then call this method. So once processing has completed, we'll call raiseEvent once more to call the complete method. And between these two lines of code, we can put our actual processing. And once we have declared all our methods, we can mark it as end interface. The last part we're going to put in this processing class is to declare an event interface to be called by raiseEvent by the server. And we're specifying the event source as iStatus. So before we add any additional code to our classes, let's now go into the pbmain function. In here, we're going to create a couple of local variables to reference these objects we have just created. Firstly, the processing object, and next, the status object. Again, I'm prefixing each of these variable names with O for object and I for interface. Next, we'll actually populate the oProcessing and the oStatus variables. The execution of both of these commands will create the instance of both of these objects, the processing object and the status object, which is handling our events. Next, we have to connect the event handler interface to the event source interface by using the events from command. Quite simply, oProcessing call oStatus. Now that we have all this set up, we can now call the runProcess method in the iProcessing interface. Quite simply by specifying the name of the object, then a dot, and then the name of the method. So that will be oProcessing.runProcess. Once that runProcess method has completed, we can then disconnect the event handler interface from the event source interface by using the events end command, like so. Now we don't actually have any processing in this application yet, but we have enough of a skeleton here to test the application. If we try running the application now, we will get a message on our console. It gives us the started processing message and the completed message. So our statuses are triggering quite happily when the processing gets to that point. So in order to put some processing in, we need to change the runProcess method. So between these two raise event commands, one to say started and one to say complete, we need to put some code in here. So first, I'm going to put a sleep command in to make it sleep for 1 second, to simulate some processing. Next, I'm going to declare two local variables. These two variables are going to be used in a for next loop. This for next loop is going to run between the numbers 1 and 4, which is the value of our total variable. For each iteration of this loop, we're going to sleep for 1 second. And after the completion, we will sleep for another second, and then we'll use the raise event command to mark the processing as complete. If we run this now, it would run quite happily. It gives us started processing, it runs for about 4 seconds, and it should give us a message to say it's completed. However, if we wish to report on the status after each stage, we want to use another method, a progressing method. So we're going to trigger another raise event against the interface for status, using the progressing method, passing it two parameters. First of all, the current number and the total number. This way, this can be used to report on percentage progress of the processing. So we now need to go back to the interface for status and add this new method. So here is a new method called progressing, taking its two parameters, one for the current progress and one for the total. The structure is much in the same way where you would declare a function or a subroutine. And we're going to create a local variable within this method called %, and we're going to perform a percentage calculation. Quite simply dividing the progress by the total and multiplying by 100. And we're going to use the log command to send a message to our console to say the process progressing is now at this percentage. So now that we've completed that, can we run the application again and see if we get the progressing method triggered after each stage of the processing? So if we run our application now, we can see it started processing, and after each second we're getting a trigger of the progressing method, telling us the 25, 50, 75 and 100% have been completed. And at the end we get the completed message to say that all processing has now completed. So in summary, what we've created today is a class to handle processing. This processing class has a single method to run our process. However, within this method, we have a number of raise event commands, which are triggering a status class. This status class is set up as an event, and that event has three methods, one to say started, one to say complete, and a third and final method to report on the progress of our background processing. Although we are currently running this application in the console compiler, it would run quite happily in the Windows compiler also. So let's load up the Windows compiler and try it out. So here we are with all exactly the same code in the Windows compiler. So we try running the application now. It will bring up a text window and give us the same output. To say it started processing, it will report on each stage, and then eventually it will give us the completed message and allow us to exit the application. So as you can see, this approach using classes is very useful for reporting progress in background processing. And this will give you a template if you wish to create such classes within your own applications. However, that's it for today. Thank you for watching.